In this video, I'm going to be teaching you everything you need to know about your sine and your cos graph at the same time, and I'll also be hinting you or showing you some of the possible questions that the lectures they don't normally get into much detail into, but would rather later ask them in the semester test or your exams. So basically, after watching this video, you will be confident when it comes to this chapter, and you will be able to back those marks. So yeah, first things first, if you are given two equations like this, remember how you would have them in your standard form. You always have your y is equals to your a sine of bt plus c. Then this side, what do you have? You have your y is equals to your a cos bt plus c. So this will also help you in your multiple choice questions. If they give you something like an equation like this and they tell you to tell us what is your amplitude, what is your vertical shift, such questions, so you will know your C. This one is normally your vertical shift. Even here, this is your vertical shift. So your A, this it's your amplitude. Also applies to this one. This is your amplitude. Then comes your what? Your B. Then comes your B. Your B is given as what? Your B is always given as your 2 pi over period. So this basically helps us to calculate our period, because now you know that if you were to calculate the period, you would make the period the subject of the formula and say your period now would be 2 pi over b. 2 pi over b. Remember, from this one you just cross multiply. This would be your b multiplied by your period is equals to your 2 pi, then you divide by b, then you get here. You see, so those are some of the stuff that you have to remember. So now, before we can be able to draw the actual graph, we are supposed to write those ones down. So okay, I just hope you'll be able to remember them. So we're just going to note them down, that we will have our A, B, C, our A, B, C. That okay, what is our A? We said our A is our amplitude, but one thing to note is that our A will always be positive, because why? It's a measure of distance, specifically how far the graph goes from the middle line to the peak. And where do you normally note your A? Your A, you normally find it next to your function name. Like in this instance, you have your 2 sine. This side you have your 2 cos, but always remember that it's given as positive. So you will see even in your book they just take it as an absolute value, because your absolute value measures a distance, and a distance can never be positive, can never be negative. It's always positive, or it gives a positive outcome. So from this, we're going to just straight up say it's 2. Then this side, we'll just say we have an absolute value of A. Then we're going to be having 2. This is the same as having an absolute value of -2. Then we know absolute value of -2 is just going to be 2. You don't actually have to write this sign to show that your absolute value of A. You can just straight up write the answer as it is. You just have to remember that even if it's a negative in front, you'll just come and write the amplitude as it is. You see, so now we move to B. Remember, I said you are going to be having your B within this part as I've indicated. Let me just repeat that one that like I've written in standard form. I said you would have your y is equals to your A sine bt plus c. But you see, sometimes they can even play around with you. They took this one and wrote it this side, but that doesn't change anything. It's just to trick you if you aren't aware of the standard form. So if we know our B is also going to help us to be able to calculate our period. So our B is here, as you can note. So our B is this one, which is this one. This is the same as having BT, but here we have 2x. So it means now here you can just say you have your 2. So before we write our C, we can also say that our period will be equals to what we said. The formula for period would be your period would be your 2 pi over b. Your period is your 2 pi over b. This would be your 2 pi over 2. So now it means our period is going to be this. We'll cancel this. It's going to be pi. Then we come and say what would be our C. Our C, that is the vertical shift. It's given here. It's -4. Then let's go to this side. What do we have? We still have this side, the standard form y is equals to A cos of bt plus C. Then you can see that when it comes to B, we're focusing on this side. But how can we write it if it's in this form? If you can notice, this is basically having your 1 over 2 multiplied by your t. So it means from this one, if you're comparing to this one, this will be your B, then this one will be your t as it is. So the letters, they didn't change. We still have your t and t like that. So that means we can just say our B would be equals to 1 over 2. So since our B is 1 over 2, we can use this to calculate the period and say your period will be equals to your 2 pi over b, which would be equals to your 2 pi. Then we will say we're going to divide by the 1 over 2. Then we know if we're dividing, we can just write this as 2 pi multiplied by, if we're dividing, we can just change the sign and flip this number by 2 over 1. So this is basically having your 4 pi. You see? So we're going to come and say, what is our C? Our C, it's 3. So I just hope from this part now, you were able to follow along on how we are finding all these values, because as I said, they can just ask you randomly in your MCQ that what is your A amplitude, what is your value for B, what is your vertical shift. This is basically how you do them. And another question that I said they might use it to catch you off guard is that they might give you a function that looks like this, or even this one, and they ask you what is your minimum value or what is your maximum value. So you can also just pause and try to think about it and how you would approach it if it was a test or an exam. So basically how you would find your maximum or your minimum value. So this is a off-topic question. I'm just adding to this one so that you know everything when it comes to your sine and cos. Remember, we have these two graphs. We have this one and this one. How do you note the graph of cos? It's always looking something like this, which is more like a W shape. So I would always just call it cos, just to remember with the W in the middle. So with this one, I would just know that, okay, the S would basically represent the shape of the graph. So how would the shape for this one go? You would have your first S being like this, then the second one will come, then the third one would be something like this. So these would be your normal cos graph and your sine graph. So that's basically how you remember their shape. And now, how is this going to help you determine your maximum and your minimum? This is the trick. You basically have to remember the range that your graph always oscillates between -1 and 1. Even this one is the same. It's going to be oscillating in between 1 and -1. So how you find your minimum and maximum, you are going to take this 1 and -1 and put it into this function. Even when you're coming to this side, you just put your 1 and -1 into this function. Then it gives you your minimum and your maximum, which is basically the explanation that it's going to be oscillating in between that -1 and 1. So that's basically how you find your mean and max. But since we're not doing that, let me just erase it quickly. So we got this one. I just want to write everything nicely at the top so that we have enough space to do the actual graphs this time. So here, since we've already followed, I can just say our graph, our period, it's 4 pi, because now I want us to at least maybe work out the table. So you would have your table. You know you're going to have your xy, then you're starting with your 0, then you're starting with your 0. So the safest way that you can use or draw your graph, it's always to use your 4 quarters, excluding your 0. So it's 1, 2, 3, 4. You will see even when you're drawing that graph, it's just going to come out perfect. You see? So excluding that 0, you're going to use this 4 quarters, 1, 2, 3, 4. Even this side, 1, 2, 3, 4. So you're using 4 quarters for a graph that is going to come out perfect. So now comes the part where people get stuck. You see, now they've given you your period. So if your period is given in this form, it's given in a form that we call these ones your radians. So in this video, I won't be teaching you about radians, but I would rather teach you a formula that you can use to avoid working with your radians. So we're going to be converting these radians to actual numbers or degrees. So we know if you're having numbers, it's just going to be easy. Because if you are working with radians, you know, okay, your radian for pi, this one, it's normally your 180 degrees. Then your radian for 4 pi, this one gives you your 720 degrees. I know this once because I do radians. But if you don't have experience of radians, what can you do? You're going to use this formula, because you see how I've worked this from radian to degrees, from radian to degrees. You're going to say, what do you have? You have oh yeah, if you want to find out, you will say you have your degrees is equals to your radians multiplied by 180 over pi. So you want to work out what is the degree for a pi. So you'll say this one, your degree will be the radian. The radian is what? It's pi. You have your pi multiplied by your 180 over pi. And as I've said, your degree is going to be what? 108. You do the same this side, you will see you're going to be left with 4 multiplied by 180, which is going to give you your 720. If you are still using this formula to get your degree. So I just quickly did it in the head. So it gives you the 720. Now comes the important part that you also have to note. You have your period, which is 108, and I said you should at least maybe choose 4 quarters that you're going to be working with, excluding this 0. So now it means you're going to be having what? You're going to be having this 180, then you're going to divide it by 4. Same thing this side, you have your 720, you divide it by 4. Then your 180 divided by 4, this gives you what? This gives you your 45 degrees. Then this gives you 180 degrees. So now how are you going to work this one or continue with your values? You're going to say here you have your 45, you add for another 45, you get to your 90, you get another, you add another 45, you get 135, you add another 45, you are back to that 180 degrees. You see, so in this one here you are going to have your 180, then 180 plus 180 you have your 360, 360 plus 180 you have your 540, then 540 plus 180 you get back to that 720. As simple as that. If you don't want to use your degrees, but I always feel like your degrees are much easier to work with, you are still going to use your radians if you're comfortable with your radians, because we know your 45, it's what? Your 45, it's pi over 4. Then your 90, it's basically your pi over 2. Then your 135 is 3 pi over 4. Then your 180 is your pi. But if you haven't studied your radians or you're not comfortable with them, I'd rather stick to this method. Then you're going to go and simply punch these ones on your calculator. You're going to get your -4, your -2, your -4, your -6, and your -4. So this one you will get your 1, you will get your 3, you will get your 5, 3, 1. So something like that. So now you have to actually plot them. You have to plot them. Okay, if you're plotting them, I think I can just like leave much space in the bottom, that okay, I'm going to be having my -2, then I have my -4 and my -6. Then I think you can just do lines like this. Do lines like this. lines like this. Then remember I said you're going to be having these 4 quarters, so you're going to have 1, 2, 3, 4. So your graph will always come out perfect. Here you have that 180. You have that 180, not the 180. Sorry. We're focusing on this one. Here you have that 45. Here you have that 90. Here you have that 135. Then here you have that 180 degrees. Then now we go back and check. When we are having a 0, we are going to have a y value of -4. So the first point is here. Then when we are having 45, we're getting -2. The second is here. The 90, it comes back. Then the 135, it goes here. Then the 180, you're getting your -4. So basically you're going to be having a graph that looks like that. So now we move to this part and draw the graph and see how it looks like. So this graph, it's more on the positive axis, so I can do this. Then we'll say we have 1, 3, 5. So we're having this lines. So also, as I said, 1, 2, 3, 4 quarters that we divided by. We have 1, 2, 3, 4. We go back and check. When we're having our 0, we have 1. That's this one. Then when we had our 180, remember here we have that 180. Then we have that 360. Then that 540. Then that 720. When we have 180, we have 3, then 360, we have 5, then 540, it comes back to 3, then 720, it comes back to 1. So you're going to be having a graph. Yeah, it's just going to be a graph that's like that shape. Yeah, it's just you're going to do it more perfectly on your side, because here I'm just using a freehand, but it's just going to be a graph that looks like that. So now you see how all this information that we've used together actually helped us to be able to draw this graph. And since now you've drawn this graph by changing this radians, you can actually use the very same formula to work back and get your radians back. Remember, what did I say with that other one? I said your degrees is equals to radians times 180 divided by pi. Where can I actually write it? I'm looking for space, but yeah, let me just rather erase this one graph since we've drawn it, just to explain this thing that I want to explain. I said the degree is equals to your radians times 180 over pi. So you've drawn your graph and now you want to change these ones into your radians, because when you were doing your period, you got your pi and your 4 pi. So yeah, maybe perhaps you don't want to show them that you don't actually know or understand the radians that much, but you still want your you still want your answers to look the same as the ones for the lecture. So you're going to say here you have your 45. Basically you're working them backwards. You're going to say here with this one you have, okay, before we do this, we can just like make radians subject of the formula. you will say you have your radians. Your radians will be equals to your degrees multiplied by your pi over 1/8. So when you come back to this one, let's just say now you're calculating for this point, you will say you have your 45 multiplied by your pi over 1/8 on your Casio. So when you punch it, you will see that it's going to give you your pi over 4. So you can just like erase this, because like you would have drawn them in a pencil, or even if you leave them as 45, 90, 135, 180, it's still fine. But I'm sure they would have left them in this case, because I know how your calculus lectures would be like. Then if you still have time, you can do this. You will get your pi over 4. Here you convert, you will get your pi over 2. Here you convert, you do your 3 pi over 4. Here you convert, then you get your pi. Basically, you see, you just drawn this graph without actually having to use any other way to do your radians, you see. So you avoided radians, then you did your thing, then now you just convert with your Casio, then it tells you the radians. You see, when you just like enter this as it is, it's going to give you 4, pi over 4. Then you write it as it is. Also in this one, or this graph, you do the same. So yeah, you can also just like let me know what you think about your sine and cos, and also in the comments if you were able to spot how you would find your maximum and your minimum in this case. So yeah, I'll see you in the next video.